Mikyas, good morning. Good morning. I think Ergave, she has to join.
Good morning, ma'am.
Good morning. Good morning. So yesterday we had started with the computer programming for the continuous beam, but you have missed it. Lightly, I'll explain today, and then I'll proceed to the subsequent steps. Ergave, whether she will join or not. She's not joining. Mikyas, any idea whether she will join or not? Ergave, any internet problem or something?
I don't know, ma'am.
You don't know. Can you just text her something? Because I'm
Okay,
calling.
okay, I
Yeah,
will call her. Okay.
yeah. Just to tell me whether you are able to see this. What is this? 1 minute. Whether you are able to see the slide share? Somebody can answer me. Okay.
Yes, sir.
Yes, ma'am.
Okay. Where she has joined? There, Gabe.
She not answering, ma'am.
Net problem. Huh? Once again, I'll call her. Whether if it's because yesterday you have some net problem in your area.
Power problem.
Power cut. Okay. Okay, I'm calling, but she's not picking up. Okay, we'll start. Okay, she's not picking up. Okay, we'll start. So yesterday, because we have started the second unit, and this is about a computer programming of the continuous beam and the what is that? The continuous beam and the 2D frames. So we have started with this is a problem I have given, and this is this beam is having 3 members. And the 3 supports, the first 3 supports are hinge support, and the last one is the fixed support. So we have started with the problem, that is you have to give the because the computer won't know uh, to that is to understand the length of the member or the properties of member, how much load is applied. So we have to give as an input. So what are the input we have to give? We have to give what is the what is the first thing is number of members you have to give. So number of members, how many number of members are there, how many supports are there, how many supports are restrained, how many joints are there, then only the computer will understand. So all the details you have to incorporate inside, and you have to incorporate what about the value of ei value for each member, and length of the member also incorporate. We have to we will incorporate in the way that is we will take this as 0 coordinate, and this is x coordinate is 0 0, and here also the coordinate is 6 0, and this is 8 0, and this is sorry, you have to start from here, that is 14 comma 0, this is 19 comma 0. So you have to origin is here, origin is from here, and you have to calculate it. So the joints are given, then you have to connectivity, how which joint is connected with the which joint, that also we have to give. The first member is being connected with the, so I'll just start the program. So I told number of members is equal 3. You can get the explanation from the, that is yesterday your classmates have noted for what is M, what is NJ, and all. So you can get from them. And M is equal to 3. Number of members is equal to 3. Number of joints, if you take the joints, this is the diagram. So number of joints is equal to, this is the first joint, second joint, third joint, and the fourth joint. So number of joints is equal to 4, and number of restraints. Number of restraint means here it is when you start numbering. This is the way we have done in the class. So 3, 4, same way you have to number it, then only it will be easy for you. 7, 8. When you start numbering, this is restrained. 1 is restrained, 3 is restrained because vertical movement is restrained, 5 is restrained, 7 is restrained, 8 is restrained. So number of restraints are NR. I have indicated using the word number of restraints. 1, 2, 3, 4, 5. Number of restraints are 5. Number of restrained joints are, how many joints are restrained? 1, 2, 3, 4. All the joints are, suppose if it's a cantilever beam, the restrained joint is only this one. This joint is free. This joint is free. So number of restrained joints are only 1. So in this case, you have a hinge support through the beam, and at the other end you have a fixed support. So you totally the number of restraints are 5, and number of restraint joints are 4, and then you have to move on. There is maximum, this stuff I think you need not worry about this one, I'll explain later. And E value you take it as 1, because in the question it is given as EI value. So E take it as 1, then we will incorporate the value of EI in the later part of the program. And here the joint coordinate, then you have to number the joint coordinate. As I told, this is the 0 0 coordinate, this is 0 4 6 sorry 6 0, then this is x coordinate is the length of the member is 14 comma 0, then this is 19 comma 0. So origin is from here, and you have to make it. So I have given x coordinate of the joint, x coordinate of the member 1. So this I have taken as member 1, member 2, member 3. So the member 1, the coordinate is x coordinate 0 0. Sorry, you have to take the joint. Sorry, you have to take the joint. Joint only you can talk about the coordinate. So the joint first coordinate, it is x of 1, joint 1 is equal to 0, y1 is equal to 0, y coordinate is 0. For the second joint, x of 2 is equal to 6, and y of 2 is equal to 0. And for the third joint, it is 14 and 0, and the fourth joint it is 19 and 0. So this is over. Then you have to give the member information. What are the number of member information? Number of degrees of freedom for a joint. For example, if you take this beam, degrees of freedom for a joint is equal to, usually for the beam we will number as 1 and 2, this is 3 and 4, excuse me. But in the case of frame, how will we number? We used to number like this, that is the horizontal is 1, because we used to consider the horizontal moment also. The vertical is 2, and the moment is equal to 3. Then we will number this joint as 4, 5, 6, like that. So when you think of the possible degree of freedom, possible, I'm talking about the possible degree of freedom. Here everything is free, but here the possible degree is 3, but is restrained. But it is for this particular beam, it is restrained. So possible degree of freedom is 3 for this one, but actually it is restrained. No degree of freedom is there. Suppose if this is a hinge support, the possible degree of freedom is 3 and the restrained are 2, like that. So for the beam, we will have degree of freedom for a joint is 2. But if you come to the frame, degree of freedom for a joint is 3. So that's the difference. So I have given us number of degrees of freedom for a joint is 2. This is a possible degree of freedom. There's a difference between the possible and what is actually available for this structure. Then total degree of freedom is equal to number of degree of freedom for a joint into number of joints. For example, this joint is having this joint is having 2, this is having 2. So number of joints is equal to, let us take, if you take this problem, number of joints is equal to number of degrees of freedom for a joint is equal to 2. So what is the total degree of freedom? 4. 1, 2, 3, 4. So total degree of freedom only I have given us ND. ND is equal to, NJ is equal to number of joints is equal to number of degrees of freedom for a joints. Number of NDJ. NDJ is equal to, so number of joints 2 for this problem. Number of joints 3, 4 for this problem. And NDJ, number of degree of freedom for a joint. That is a possible degree of freedom for a joint is 2. Even though it is restrained, but possible is 2. It can, if it is hinged. Suppose if the beam is hinged like this, the possible is 2, but 1 is restrained. This is free, like that. So there is a difference between NDJ, NDJ and ND. ND is equal to total degree of freedom for this structure is equal to number of joints into number of degree of freedom for a joint. So that is equal to ND. So if you take here, number of degrees of freedom for this joint is ND is equal, total degree of freedom is equal to NDJ into NJ. NDJ is equal to 2 and ND is equal to NDJ into number of joints. That's 2 into, this is equal to 4. Number of joints is equal to 4. So total degree of freedom is 8. This NDJ is equal to 2 and 2 into 4 is equal to 8. So when you count like this, 1, 2, 3, 4, 5, 6, 7, 8. So this 8, it is the computer is calculating by this step. Then this is what I have calculated is possible. What is the possible? But for this structure, how many degree of freedom is there? So how many degree of freedom is there? This is free to rotate because it's a hinge joint. This is free to rotate. This is free to rotate, but this is restrained. So possible the number of degrees of freedom available for this particular structure is 1, 2, 3. 1, 2, 3. 3 possible rotations. Not possible. It is 3 rotations available for this structure. So just check it whether we are getting the answer is 3. ND is equal to 8. ND is equal to 8 because this step has calculated. ND is equal to 8. The previous step has calculated. ND is equal to 8. And NR is equal to, already we have given the NR value. NR is equal to 5. So 8 minus 5 is equal to 3. So this we have completed. And MD, I think I didn't explain it yesterday. MD is equal to member displacement. Member displacement is equal to NDJ into 2. NDJ into 2. That is, for a member, 2 joints are there. Any member, you will have only 2 joints. So this represents the number of joints. NDJ represents number of degrees of freedom for a joint. So 2 into 4. So for each member, you will have 4 degrees of freedom, possible degree of freedom. Each member, you will have a 4 possible degree of freedom. That's what I have given by member displacement. Member displacement. Possible member displacement. If you want to write possible member displacement. Member displacement. Then I have we have moved on to member coordinate. Member coordinate is how the member is being connected. 1 minute. how the member is being connected. That is, the first member is connected with the how it is being connected. I'll represent this end as J, this end as K, J and K. So it is connected with, if you take this for first member, I'm taking the member, it is connected with the node numbering. What is the node numbering? 1, 2, 3, 4. So the first member is connected with 1 and 2. This is first member. If you move on to the second member, it is connected with 2 and 3. 2 join and 3 join, third join. So second member is connected with second join and third, J and K. So I given, if you take this first member, J of 1, that is for the first member, or J of 1. J means joined. Joined. J of 1 is equal to 1 and JK. K is equal to 2. It is connected with 1 and 2. That's what it is representing here. That is here J and K. But the moment of inertia, EI value is equal to, when you move on to the previous slide, you can see the moment of inertia is equal to 27,000 for first member and 51,200 for the second member and 25,000 for the third member. So that's what I have. And if you go on to the second member, it is connected with 2 and 3. So I have written here for the second member, it is connected with the 2 and 3. 2 and 3. And moment of inertia also given. Third member, if you move on to the third member, it is connected with the, if we go here, it is connected with 3 and 4. 3 and 4. So J is 3 and K is 4. Here I have written. J is 3 and K is 4. So the member. So what this here represents the inside. JK of 3 means third member. But here what does it indicate is the joint. That is, you go to that and move here. So if you, this is the joint and sorry. This represents a joint and this represents a member. So 4 joints are there. For the joints, you have to give the coordinate, and for the member, you have to give the connectivity. How the members are connected. Because why it is, you have to give the connectivity. But in the case of, if you take the frame, if you take this member as 1, let us start the connectivity as joined as 1, 2, 3, 4, and this is the second member, this is the third member. So 1, 2, 3 and 4. So if you take this one, we will take the connectivity as if you take the member 1, the connectivity is 2 and 3. And for the member 2, connectivity is 1 and 2. J is 1 and K is 1. Mikas, you are able to understand what I'm explaining? I'm a little bit fast only. You are able to pick up?
Yes, ma'am.
Yeah, you just go through. If you are getting any confusion, you can ask me in the subsequent classes, because I explained everything, because we have to finish the portions very fast. And if time permits, we can do the revision, because when your exams are going to happen, we don't know. So we have to hurry up and we have to complete the syllabus a little bit earlier. And if possible, because it's online, means if I can take extra classes also, no problem. So if you are finding any difficult, you ask a classmates, or you can ask me in your next classes. If possible, you just help Ergabe. I don't know whether she has joined. Did she join, Ergabe? Can you just check and tell me? Because when it is in the slideshow mode, I can't see. She hasn't joined? No. Okay. Anyway, we will see. Otherwise, I'll teach her. So up to this one only, I have explained yesterday. So today we will start with the joint restraints. So the computer, initially we should know there's some term called initialization of the program. Initialization of the program. Something we have to give us 0, that is, it's a for loop. For loop. There is a for and end word you can see here. This is called for loop. So for j is equal to 1 to n, 1 2, that is a semicolon, that is, 1 minute, I'll rub it off everything. Okay, so it's something called initialization of the program. So here what we are doing is, here is, this is called initialization of program. What we are doing is, for j is equal to 1 to, this represents, colon represents, sorry, semicolon represents nd, 1 to nd, and you have to, and one more thing I have, because I have forgotten to tell you, if you are putting the semicolon, then the program, the answer will not be displayed on the screen. If suppose if I am writing for j is equal to 1 is to nd, then the answer will be displayed on the screen. If you are putting this semicolon, it will not be displayed on the screen. And one more thing is, I've forgotten to explain you, that is, whenever you are using this percentage something, this particular line, the computer will skip off. It will not take into account. So whatever something you want to tell or narrate for your convenience, then you have to use this percentage joint coordinator. So that you have to do it. So for j is equal to 1 to nd. What is nd? Nd already we have calculated, no? Nd is equal to 8. Nd is equal to 8. It is, we have numbered, no? 1, 2, 3, 4, 5, 6, 7, and 8. 7 and 8. So for j is equal to 1 nd. Nd is the number of displacement, total number of this possible displacement. So nd is equal to 8, up to 8. What will happen? You have to take, you are taking everything is restrained. J R L of j. J means this j. J R L of j is equal to 0. So initially it will keep it as all the joints are restraints. All the joints are restraints. It will keep the degree of freedom is equal to, it will take it as 0. It will take it as 0. And it will complete. That is, it will take, for j is equal to 1, the answer will be, and it will, it's a loop. First it will take j is equal to 1, and it will go to the next step. Next step, what I'll write? It is j R L of j is equal to now 1. 1 is equal to, 1 minute, I'll clear it off. So we start from here so that So what is happening for j is equal to 1 colon nd j r l of j is equal to 0 and end. So the output for this particular thing is first the computer will take j is equal to 1. So what has happened? J R L of 1 is equal to, what I am writing is the answer, is equal to 1. So it will do up to nd, up to 8. Nd we have calculated now here. Nd is equal to 8. So up to 8 it will check. Then it will again do it. That it will go. It is not completed. So it will go JRL of 2 is equal. Now it will become incremented by 1 by 1. So 1 is to ND means now it will be incremented by 1. That is 2. It will become 2. So JRL of 2 is equal to 0. Now it will be incremented by 1. So JRL of 3 is equal to 0. JRL of 4 is equal to 0. JR. So whatever description I'm giving, you just put a column like this and a line like this and you write the description so that you will not hinder anything with the program. JRL of 5 is equal to 0. Again, it is not completed because it has to go up to 8. So then JRL of 6 is equal to 0. Then JRL of 7 is equal to 0. JRL of 8 is equal to 0. So once the value comes to 8, the computer will understand we have to stop it. So the program will terminate. That is, it is the end. So once it has gone to 8, because it has to do it. Suppose if it is 10 means it will go up to 10. If it is 12 means it will go up to 12. So it will, computer will know where we have to, like a human brain only. So it will terminate here. Once it reaches 8, it will terminate. Can you just note it down this point? So whatever I have written here, you can write this. This is a output. This is the output. Suppose if you're not putting the semicolon here, then you can get the output like this. JRL of 1 is equal to 0, JRL of 2 is equal to 0, JRL of 3 is equal to 0, JRL of 4 is equal to 0, and 5 is equal to 0. Like that, you can get the output in the screen. So can I just copy down and this also, this is a output. Just you put the value as output and you write here for your explanation purpose. Because you also start right, the previous thing you can collect from your friends. Finish writing. Now you have to tell 1357 or 13578 are restrained. So we are here, we are taking whatever is restrained as 1 in the program, not restrained as 0. So you should not get confused with the classwork. So whatever is you write, that is in the next page you write, whatever is restrained, we have to take it as, if you go to the this one. So what is restrained here? Just you look at this restrained or 1 is restrained, 1, 3 is vertically restrained, 5 is restrained, and 7 and 8 are restrained. Because it's a fixed support, it can't rotate, but this can rotate, this can rotate, this can rotate, this can rotate. So but this end can't rotate and it can't move upward also. So 7 and 8 are restrained, and 5 is restrained, 3 is restrained, and 1 is restrained. So restrained things, I'll take it as 0. I'll, sorry, 1. I'll take it as, in the class we have taken as 0. Am I correct? U1 is equal to, we have taken U1 is equal to 0, U3 is equal to 0, U5 is equal to 0, and U7 and 8 are is equal to 0. So please don't get confused with that one. Now I'm taking the restrained as 1 for the computer programming. Restrained as 1, 3, as you notice, no? 1, 3, 5, 7, 8 are restrained. So put a restrained joins restrained movements or rotations, whatever it may be. That is, here it is movements only, movements, and are taken as 1. So this is very, very important. Don't get confused. So what will happen to the computer? Initially, what I have done, JRL of 1 is equal to 0, JRL of 2 is equal to 0, JRL of 3 is equal to 0, JRL of 4 is equal to 0, JRL of 5 is equal to 0, JRL of 6 is equal to 0, JRL of 7 is equal to 0, JRL of 8 is equal to 0. Now what will happen to the program is, now I have given some other instructions. So what automatically the computer will change, JRL of 1 is equal to 1. Now it is, initially we have initialized everything as 0. That's why I call it as initialization of the program. So now I have taken 1 is equal to 1. So the computer will change this as 1. In this replace as 1. Whatever we are giving to the further steps, it will take the as a new step. Then 3 also it will take it as 1. 5 also it will take it as 1. 7 also it will take it as 1. And 8 also 1. So restrain things, it will take it as 1. Any confusion, any doubt in this one? Jagan and Kaleris and Sweda, Kritika, any doubt in this one after this subject? Mikyas also? Any doubt in this one? No. Okay. So now this the computer, it will not you will not have this value. Instead of that, you will have the values 1. So this is a new thing the computer has kept. Now we didn't tell anything about only we have talked about the coordinate, joint coordinate, but we didn't tell anything about the length of the member. If coordinate is given, when we can calculate the length of the member. So now we have to tell, have you written this one? Write this one, the explanation you write for this step, you write the explanation. If you are finished, we will move on to how to calculate the length of the member.
Ma'am.
Tell me.
Ma'am, at the left-hand side, ma'am, whether it is an input or output, ma'am.
Which one?
JRL of 1 is equal to 1.
This is output. This is output. This one we have to give. Actually, this is the input we have to write to the program. So when you are writing the program, some things we have to give, something automatically. So we have to write this way. This is the same way we have to write the program. But ND and all, you need not give us 8 because it will vary from the problem to problem. So you can do this, you can apply this program not only for this one, any type of. So what are the inputs we'll give? For example, these are the inputs we have to give. That is, m is equal to 3, you have to give, nj is equal to 3. Depending upon the problem, you have to give all these values. Then the coordinate also you have to give depending upon the problem. This step you have to give, this step you have to give, and ndj you have to give. This step actually it will automatically calculated by the computer. This step also automatically calculated. This step also calculator, and these are the inputs you have to give. And this is automatically, it is a inbuilt one. That is, it will not vary from problem to problem. So whatever I am putting tick, you have to give us an input. So this also you should give us an input. So this you have to write JRL of 1 is equal to 1. So this is an input, 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 input. So this is the output you are getting. If you want to see the output, then you can you have to remove the colon, that is sorry, semicolon from here, and you can see the output in the screen. Now we will move on to the calculation of the length of the member. So I'll rub it off this one. Now we have to calculate the length of the member. So length of the member you have to calculate. So whatever you are putting in the percentage, it will not take into account. The computer will not take into account. But for our clarification or for our understanding, we have to write this. Then length of the member it has to calculate from for I is equal to 1 to m. You can take any notation. You can take z also. For z is equal to 1 to m, you calculate something, it will calculate. But m is the number of members. Number of members. Initially, we have defined, initially the first line we have defined is the number of members. So m is the number of members. Number of members. M is the number of members. So how many number of members are there in our problem? It is 3. Am I correct? We have given 1, 2, 3. So 3 members are there. So the program will run for up to 1 to 3. So for 1 to 3, something has to be calculated. What has to be calculated? XCL of XCL of is equal to absolute value of, what is j of k? J of k, this is 1. J of k, it will take j of k is equal to j of k is j of k of I. Now I is for the first member, it will calculate for the, so let us take m is equal to 1 now. The first output is m is equal to 1 now, and sorry. This is not m is equal, this I is equal to 1. I is equal to 1. Let us take I is equal to the first member. It is the first member. For the first member, it has to calculate the length of the beam. Length of the beam. What is the length of the first member? It is, what is the length of the first member? Somebody can answer me? Is it 6? Yeah, 6. So length of the member is 6. So we will at the completion of this one, we'll check it whether we are getting the answer as 6. We should get the length of the member as plus 6. It's not minus 6. We should get it as plus 6. So we'll check it whether we are getting this one. So first you go inside this jk of I is equal to 1 now. What is jk of 1? Jk of 1. Jk of 1. Jk of 1 is equal to, jk of 1 is equal to, what is the value? Jk of 1 is equal to 2. Jk of 1 is equal to 2. Here we will write it as 2. Jk of 1 is equal to 2. What is x of 2? So this has become, jk of 1 has become 2. Jk of 1 has become 2. And one more x is there, x of 2. What is x of 2? Go to the previous step and find out x of 2. X of 2 is equal to 6. Am I correct? X of 2 is, am I correct or not?
Yes, ma'am.
X of 2 is equal to 6. X of 2 is equal to, so I'll write here, x of j k of I. This is jk of I is equal, I has become now 1 and jk of 1 is equal to 2 is equal to x of 2. That is, it will become x of 2. X of 2 is equal to 6. What is this one? J of 1. That is, j I will become 1. I will become 1. So I'll write. That is for I is equal to 1 to m is equal to 3a. Then j k of, that is, I has become 1. I has become 1. J k of, sorry. J k of 1. Then that should be followed by x. So jk of 1 is equal to 2 and x of 2, that is x of 2 is equal to 6. X of 2 is equal to 6. Now I will move on to this step. J x of j of 1 is equal to, what is j of 1? J of 1 is equal to 1. What is x of 1? X of 1 is equal to 0. Okay. X of j of 1 is equal to 1. This is equal to 1. So x of 1 is equal to 0. So what will happen? This I have calculated as 6. This portion as 6 and this portion as 0. So 6 minus 0 is equal to 0. Oh, sorry, 6. 6 minus 0 is equal to 6. So if it's a beam problem, it is enough. This x value is enough. If it's a, this is, what is that? This is a frame problem, what will happen? It will have a y coordinate also. Then you have to calculate similar way to y coordinate also. So if it's an inclined member, what will happen? How to find out the length of the inclined member? Inclined member, if you know the x value and the y value, I can find out this value. That is, what is this? This is x, this is y. Oh, so what is the length of the member? Length of the member is, length of this member is equal to square root of x square plus y square. X square plus y square. So what I have calculated is x here I have calculated, y I have calculated, and I can find out the length of the member. Length of the member is SQRT of x square plus y square. So here it's a horizontal member. This value will become 0. If you want, we will check for one value. The first member will finish it up. Then I can repeat it. The first member. So whatever I am doing is for I is equal to 1. I is equal to 1. Now I will move on to the, this is the one step. Then I will, this is the step for calculating x direction, x value. This x I am calculating. Now I will move on to the y calculation. So what I have to do is jk of 1, that is x y of j k of 1 is equal to, what is j k of 1? Somebody can tell me? J k of 1?
2, ma'am.
2. So here also we have written 2. So y of 2. What is y of 2? Y of 2 is equal to 0. Am I correct?
0, ma'am.
Then I will move on to this value. That is this value. That is y of jj of 1 is equal to y of jj of 1 already we have taken here 1. Y of 1 also equal to 0. So this will become finally what will 0 minus 0 is equal to 0. This you will get the 0. So here if you are going x is equal to square root of SQRT only, you have to write square root of x square. That is x square is this value, XCL value, x square plus y square, that is equal to square root of, what is x square? X square is equal to 36 plus 0, because we have got the x value as here, no, XCL. XCL is equal to, if you want, you can write here, XCL is equal to 6 minus 0 is equal to 6. So XCL value. So this is for x direction calculation and this is for y direction. So x square plus y square. So that is equal to square root of 36. It is equal to 6. So the final answer, length of the first member is 6. That's what we have calculated. What I'm doing is you copy down this one and you can try for the second member, whether you are getting the answer for the second member, the length of the member. Can you just try? Can you just try? You put the title as for, now it will become, after calculating the square root value, it will, the loop will go further. That is, it will go to the second. That is, first member it is over. So it will, now it will become m is equal to 2. So what I am asking is, you have to do it for 2. You have to do it for 2. You have to do it for 2. You first copy down this one, then only you will, these are the output. These are the output. First you calculate these things for the first member. You put the, this is for the first member. For the first member. And you calculate for the second member and tell me the answer, whether you are getting the, I'll wait for you. Michaels, you also try to do it and you tell me the answer. For the second member, whether you are getting the same answer. Because once you understand, then the program writing will be easy. And one more thing, the open parenthesis, that is the open bracket. Open parenthesis means this open bracket, suppose if you are using, then you have a close parenthesis. 2 means here also you should have. 3 means 3. So if you are making any mistake, then the computer will show there is an error. So calculate for the second member and tell me. I is equal to, your put for the second member, it is 2. First you copy down for the first member and then you do it for the second member. If you have finished, can you tell me the answer for? Because are you doing? Hello? Hello, Mikias?
Yes, ma'am.
Are you doing for the second member?
I'm trying.
You may need this one, no? You may need this values. Just copy down the JJ of 2, what is that? And I'll show the screen so that you'll be able to do it for the second. So JK and JJ you have to take from here. And X value and Y value you have to take from here. If anyone has finished, you just tell me the answer.
Ma'am, can I show the next slide?
Yeah? No?
Next slide, ma'am.
Change the slide. Huh?
Yes, ma'am.
What is the value of JK of 2? JK of 2 and JJ of 2. Tell me the answer because
JJ of 2 is 2, ma'am.
2, JK of
JK
JJ
is 3, ma'am.
3. Okay. And similarly, X of JK of 2 is equal to, that is X
14,
of 2.
ma'am.
That is X of 2. X of 2 is equal to
6, ma'am.
6. Then this one, X of JJ of 2. That is J, this is 2. So X of 2 is, X of this is equal to 3, no? JJ of 2 is equal to 3. 3. This is 3. That is equal to X of 3. What is X of 3? What is X of 3?
14.
Okay. Now we proceed whether you are getting the same answer. Have you got the answer? Anyone has got the answer for the second member? Why so much of time? What is the length of the second member? The same program you can use it for the frame also. So that's why I've written the common way so that you need not study one program for beam and one program for the column. Sorry, frame. Both the things can be solved using the same program, while the stiffness matrix will be different. Can anyone tell me the answer? What is the length of the second member?
8, ma'am.
8. Yeah, that's the correct answer. What about Jagan? Jagan? Did you get the answer as 8?
Yes, ma'am.
Kalayarasu? Kalayarasu? Did you get it or you are trying?
Got confused, ma'am.
Got confused. Where can you tell me so that I can explain one more time?
And that JK value, ma'am.
JK,
and JJ value.
JK value, you need not confuse anything. JK of I will become 2. Am I correct? The first one I have completed. Now the increment, it will be incremented by 1 by 1. So I will become 2. So that's the difference. So JK of 2, I will become 2. JK of 2 you have to take from here, and JJ of 2 you have to take from here. What is JK of 2? JK of 2 is equal to 3 and JJ of 2 is equal to 2. So again, what will happen is, that is here, this is the thing you have to take. Second member JJ of 2 is equal to 2, and you have to write x coordinate of JJ of. So for this one, where will you go? It has become 2. It has become 2. JJ of 2 is equal to 2. So x of 2. X, now it has become x of 2. What is x of 2? X of 2 is equal to 6. X of 2 is equal to 6. What is that? Now you have to calculate what is that? JJ of 2, then JK of 2. J x of JJ of 2. BJJ we got calculator JK. JK of 2. JK of 2 is 3. So here it is given. JK of 2 is equal to 3. So x of 3. X of 3 is equal to. So you have to look here, this row, and then you have to move on to this one. X of 3. X of 3 is equal to 14. X of 3 is equal to 14. Now any confusion? This is for the second member. Am I correct? This is for the second member coordinate. So you have to look into this, and then you have to go for the connectivity, respective connectivity. That is, if it is 2 and 3, you have to go for 2 and 3. If it is 3 and 4, then you have to go for 3 and 4. Just to work it out, what you do is you do this as an homework and complete for the 3 members, and do it for your the yesterday assignment one problem I have given. No, you try for that, and I will ask you to upload. Every assignment carries marks. I'll consider it for 5 marks, and you can upload at the end of the once the program is completed. So slowly you work it out for this one. So this particular problem you have to complete for m is equal to 1 is to em 3. Your 3 members are there, and you have to do it for the other problem whatever given yesterday also as assignment. Okay, so complete it because time is over. I don't want to take your time more. Mikhail, have you got the answer? You find it? Did you find it difficult?
Understood, ma'am.
Okay, very good. Kalerisi, you try. You can ask your friends. If you still find it difficult, I'll explain you. Okay, Kalerisi?
Yes, ma'am.
Okay. You try. Sit at home and leisurely, if you try, you will do. It's not a difficult thing. Just you go through and do the assignment simultaneously. Then only you will be able to do it. So as you requested, I have given the assignment and the quizzes. I'll do it in the subsequent week. There is Monday. Tomorrow it's a holiday for you. So Monday class, we may have the quiz on this program alone. Simultaneously, you.
Advance Happy New Year, ma'am.
Thank you. Thank you. Wish you the same. Wish you the same for all the people. May God bless you all of you. And may God keep you in good health also. So wish you all the best.